Hello, and welcome. This is the third tutorial in our Excel form series. In the first tutorial, we discussed how to use Excel's built-in form feature, a ready-made tool that allows you to enter, find, edit, and delete records without using any code. In the second tutorial, we created a worksheet-based data entry form using minimal VBA code. In that form, we used worksheet cells as input fields and a single form control button to submit data to another sheet. In this tutorial, we will enhance that same form by adding more functionality. The form previously allowed only data entry, but now we will add search and update features. As you can see on the screen, if you have a large number of records and need to find a specific one, you no longer need to search manually in the data sheet. Instead, you can use the search feature directly from the form. This enhancement allows you to find, view, edit, and even delete records while staying on the form sheet, making the entire process more convenient and efficient. You've already seen how our enhanced form will work. So, let's begin right from where we left off in the previous video. As you may remember, we protected the form sheet to ensure users could only interact with the designated form fields and couldn't accidentally type or modify anything else on the sheet. So, the first step is to unprotect the form sheet. To do that, go to the Review tab and click Unprotect Sheet. Next, we'll use cell B9 as our search field. This is where users will type the employee name they want to find. Let's format this cell to make it look like a text box, so it appears clearly as a search field. In cell A9, type employee name, so users understand that the search will be performed based on the employee's name. Now, go to the Developer tab, open the Insert menu in the Controls group, and from the Form Control section, select the Button option. Draw the button near cell B10. As soon as you draw the button, the Assign Macro dialog box appears. For now, just click Cancel because we haven't written the macro for this button yet. Rename the button to Find. Next, we'll open the Visual Basic Editor, where we'll write the code for our Find or Search feature. As you can see, our existing Module 1 currently contains only one subroutine named Employee Form, which submits data from the form to the data sheet. Now, we'll create a new subroutine called Find Record and add the code as shown on screen. The first line declares a variable named EMP_name and specifies its data type as string. In the second line, we assign this variable the value of cell B9 on the worksheet named form. The third line displays a message box showing the text stored in EMP_name, allowing us to confirm that the code is correctly reading the value from cell B9. Let's go back to Excel and assign this macro to the Find button. Right-click the button, select Assign Macro, choose Find Record from the list, and click OK. Now, the Find button is linked with our new macro. Whenever the user clicks this button, the Find Record subroutine will run and execute the code inside it. To test it, type something in cell B9 and click the Find button. You'll see a message box showing exactly what you typed in cell B9. That means our code is working correctly. It's successfully reading the value entered in the search field. Let's improve our code further. We'll declare a worksheet variable named WSForm to refer to the form sheet. Since we'll be referring to the form sheet multiple times, assigning it to a variable helps us avoid writing long expressions again and again. This makes our code shorter, cleaner, and easier to maintain. Here's the improved version of the code, as you see on the screen. Next, we added an if statement to check whether the variable EMP_name has a value or not. If it's empty, that means the user didn't type anything in cell B9, but still clicked the Find button. In that case, we use the exit substatement to stop the macro immediately because there's no input to process. Now let's go back to Excel and test it. If you leave cell B9 blank and press the Find button, the subroutine ends right away and no message box appears, which means our validation is working correctly. Next, we declared a variable named FindCell with a data type range. This variable will hold the result of Excel VBA's find method, which searches for the entered employee name in the data sheet. We're using the find function to look for the value stored in EMP_name within column A of the data sheet. If a match is found, the find function returns the cell where the match occurs, and that cell reference is stored in the variable FindCell. Then, we check whether FindCell is nothing. If it is nothing, it means no record was found matching the entered name. In that case, we display a message box saying "Record not found." Clear the contents of cell B9 on the form sheet, and use exit sub to stop the macro. If a match is found, we display another message box showing the row number of the matching record using findCell.row. This helps confirm that the search worked and tells us where the record exists in the data sheet. Now let's test our code. Go back to Excel and try finding a record. If the record exists in the data sheet, the message box will display its row number. You can verify this by checking the data sheet. For example, if the message box shows 5, it means the matching record is found on row 5. Let's open the data sheet and confirm. As you can see, the record we searched for is indeed on row 5. Try searching for a few more names to verify that our code is working properly. When the record doesn't exist, the message box displays "Record not found." Now, instead of just showing the row number, let's display the entire record on our form so the user can immediately view all the related details after performing a search. We know that if the record is found, the macro continues execution, the if statement is ignored, and the search result is stored in the findCell variable, which represents the specific cell found in column A of the datasheet. To retrieve the entire record, which actually spans 4 columns, we use this line of code as shown on the screen. This line copies the found record from the datasheet and writes it into the form sheet, specifically into the range B2 to B5. The resize method is used here to expand the findCell range horizontally by 4 columns, capturing the complete record. Since the data on the datasheet is stored in a horizontal row, but on the form we need to display it vertically, we use the application.transpose method. This converts the horizontal row of values into a vertical arrangement, so the information fits neatly into the form layout. Now, remove the message box line that was displaying the row number. Go back to Excel and try searching for a record again. You'll see that when a record is found, the form fields are automatically filled with that record's details, allowing you to easily view or edit it. Notice that our code currently displays only the first occurrence of a record. If multiple records share the same name, only the first match is shown. To handle this, we'll store the location of the found record. This will allow us to continue searching from that point and find the next matching record. We'll save the row number of the found record in cell C9 on the form sheet. Go back to the VBA editor, and at the end of the subroutine, assign the row number of the found record to cell C9 on the form sheet using findCell.row. This value helps us locate the next record with the same name, and later, it will also help identify which row to update. In simple terms, C9 works like an ID for the record currently displayed on the form. Now, before going further, let's declare a new variable named WSData of type worksheet and assign it the data sheet. Since our code will reference the data sheet multiple times, it's better to assign it to a variable instead of writing the full sheet reference each time. This approach makes the code shorter, more readable, and easier to maintain in the future. Now, let's look at the code part that searches the data. Find method searches for the value stored in the variable EMP name, which is the employee name, in the entire column A of the datasheet. By default, the search starts from the beginning of the range, which is cell A1. However, we can make the search start after a specific location by using the after parameter. For example, if the record is found in cell A3 and another similar record exists in A8, using after parameter will make VBA search after A3, and it will find A8 next. This technique allows us to locate multiple records that share the same name. Now, let's see how we use the after parameter. We'll declare a variable named searchAfter of type range and assign it the range from where the search should begin. Initially, we'll assign it the beginning of the range, which means all searches start from the first cell, using the cells method. The cells method containing 2 arguments, 1 and 1 refers to the first cell in the data sheet. That's A1. Then, we'll use an if statement to check whether cell C9 on the form sheet already contains a row number from the previous search. If C9 is empty, That means no search has been performed yet, so the search starts after a 1. That's the default. If it's not empty, it means a record was found earlier, so we'll update search after to start searching after that row number stored in C9. That way, when we use the find method again, VBA knows to continue searching after the last found record, allowing us to find the next one. Finally, we update the find statement to include the after parameter. Now the VBA search for the employee name after the position stored in search after. That's how we make the search cycle through multiple matching records instead of stopping at the first one. When we try to find a record, a VBA runtime error occurred because we used the variable search after before setting it. In VBA, some variables, like worksheet or range objects, need to be set before they're used. These are called object variables, and they require the set keyword. Now the variable is initialized correctly, and the code will work without causing an error. Now, try finding some records. You'll notice our code is now returning multiple results for the same search instead of stopping at the first match. Our search feature works like a loop. Once it reaches the last matching record, pressing find again starts the search over from the beginning. Also, when no record is found, our code already clears cell B9 using the clear contents method. Let's clear cell C9 as well, so both cells get cleared together when the record isn't found. It's optional, but doing this keeps our form clean and avoids confusion during searches. Our search form is working well now. The next task is to update the found record. The main purpose of searching isn't always just to view a record. Sometimes we need to modify it. Since we're loading the searched record onto the same form we use for adding new entries, submitting it right now would simply create a duplicate record instead of updating the existing one. To use the same form for both adding and updating records, the VBA code needs to recognize the current state of the form. We'll do this by renaming the Add Record button to Update Record whenever a record is found. Select the button, right-click to make sure it's selected, then in the name box on the ribbon, rename it to Submit BTN. This makes it easier to access the button for VBA code. Now go back to the VBA editor and, at the end of the subroutine, add this line of code to rename the button. That's it. Return to Excel and try finding a record. You'll see that when a record is found, the button label immediately changes from Add Record to Update Record. Of course, clicking this button still adds a new record. Renaming it doesn't change its functionality yet. It's simply a visual indicator to tell users whether the form is in Add or Update mode. Now it's time to implement the actual update functionality. Go back to the VBA editor. We know this button currently runs the employee form macro, so we'll modify that subroutine. First, copy the variables WSData and WSForm from the Find Record subroutine and paste them at the top of employee form. This saves us time and ensures consistent references between both subs. Next, copy the line of code that renames the button and use it in a new if statement like this. This condition checks whether the button text is Update Record. If it is, the code under this block will execute for updating the record. Then write an else statement for the existing code that adds new records, followed by end if. This way, whenever the Submit BTN is clicked, the employee form macro runs. It checks the button's text. If it's Update Record, it runs the update code. Otherwise, it runs the code to add a new record. To test this, write a simple message box under the if statement. Go back to Excel, search for a record, and click the button. You'll see a message box displaying Updating. This means the condition works properly. Now let's write the actual code to update the existing record. First, update all old code references to use WSData and WSForm instead of long statements. Then declare a new variable, updateRow, to reference the row we want to update. This line reads the row number of the record we're about to update from cell C9 on the form sheet, the same value that was written there when we searched for a record. Then it uses the cells method to locate that specific row on the data sheet. Next, update the record by writing this line. Here, the resize method expands the update row range to 4 columns, while application.transpose converts the vertical layout of our form into a horizontal format, so it can be stored correctly on the data sheet. After updating, we'll rename the button back to Add Record, so the form is ready for new entries. Now go back to Excel and test it. You'll see the record updates correctly, but the data still remains on the form. To fix this, we need to clear the form. Let's move the code that clears the form outside the if statement so it runs after both adding and updating operations. This way, the form clears automatically in both cases, and we don't need to repeat the same code twice. Return to Excel again, try updating a record, and you'll see this time the form clears right after the update, and the button changes back to Add Record, ready for new input. Now, go back to the VBA editor to optimize the code. We'll move the update row declaration outside the if statement, so it can be used in both sections of the code. We'll initialize it differently based on the situation. In the else statement, we'll set it to the next available empty row on the data sheet. That way, when a new record is being added, the data is written at the end of the existing list. Inside the if statement, we've already assigned the update row variable using the row number stored in cell C9. This cell contains the row number of the record found during the search, which allows the code to locate and update that specific record on the data sheet. After modifying the code, you can see that the line writing data to the data sheet is the same in both the if and else statements. So, let's move it outside the conditional block and remove it from both sections. This way, it executes in both cases, whether the user is adding a new record or updating an existing one. Now, our code looks clean, easy to read, and free from duplication. Now go back to Excel and test it. Try finding and updating records, then try adding new ones. To test the update functionality, find a record and make some changes to it. You'll notice that when you submit the form, the record on row 18 of the datasheet is updated immediately. Now, try adding a new record. It should appear at the end of your existing records on the datasheet. After submitting the form, check the datasheet. You'll see the new record added at the bottom of the list. However, you may have noticed that after searching for a record, the search field in cell B9 and the row number in cell C9 are not cleared, even after updating the record. You still have to delete them manually before performing a new search. To fix this, let's add a clear form feature that clears all form fields with one click. Let's draw a new button on Form Sheet, preferably near the Add Tutorial button. When the Assign Macro dialog box appears, just click Cancel. We'll assign the macro after writing the code. Rename the button to Clear Form, then open the VBA editor. Create a new subroutine named Clear Form and write the code as shown on screen. This code targets the cells B2 to B5, B9, and C9 on the form sheet, and the Clear Contents method removes any data inside them. Go back to Excel and right-click on Clear Form button and choose Assign Macro. The Assign Macro dialog box will appear. Choose Clear Form from the list and click OK. Our new written code has been assigned to this button. Now clicking this button will clear the content of all fields in the form. But notice the Add Record button, which changes to Update Record when editing, doesn't switch back to its default state after clearing. To fix that, open the VBA editor again and add one more line to the Clear Form macro that renames the Submit BTN button back to Add Record. You can copy the same code line from the Employee Form macro. Now, whenever you click the Clear Form button, it will not only clear all fields but also reset the button text, making the form ready for adding new records again. That's it. Our form is fully functional and ready to use. Now, let's make it look visually appealing and easier to read. For the search label, we'll give it a dark green background and white text color. This contrast makes the label stand out clearly. For the entire form, we'll apply a very light gray background color, also known as snow white. Adding this soft background color helps hide the grid lines and gives the form a clean, polished look. Next, we'll add a thick border around the form area to make it visually distinct from the rest of the worksheet. Then, we'll move the Find button over cell C9. This will hide the row number that VBA uses internally to keep track of the record being edited or searched. It's an important design step. This way, users won't see or accidentally change the row number, preventing errors in the datasheet. Finally, to avoid any accidental changes to the form layout, let's protect the sheet. Before protecting it, we'll unlock the cells that users need to interact with. In our case, cells B2 to B5, B9, and C9. To do that, select these cells, right-click the selection, choose Format Cells, then go to the Protection tab and uncheck Locked, and click OK. In this video, we'll unlock B9 and C9, as B2 to B5 were already unlocked earlier in the previous tutorial. Now, go to the Review tab, click Protect Sheet, and in the dialog box, make sure only Select Unlock Cells is checked in the Allow list, then click OK. The sheet is now protected. Only the form field can be selected and edited. All other cells are locked and safe from accidental changes. To learn more about protecting worksheets in Excel, you can watch our dedicated tutorial. The link is on your screen and also available in the description below. That's it. Our Excel form is now complete. It can add new records, find existing ones, and even update them, all from a single, easy-to-use interface. We also optimized the code, added a Clear Form button, improved the layout, and protected the sheet, making the form not only functional but also professional and user-friendly. Thanks for watching. I hope you found this tutorial helpful. If you did, don't forget to like the video, subscribe to the channel, and turn on notifications so you don't miss upcoming Excel automation tutorials. You can also check out related videos. The links are on your screen and in the description below. See you in the next tutorial.